Let us continue solving past exam papers. The first question: which of the following is equal to the limit of what we see, the function x over x plus 2 the whole the power of negative 3x. First, let's try to recall spatial limit, the limit of any function 1 plus a over x the whole the power of mx plus b as x goes to infinity. This is a special limit which is equal to e the power of am. What's a? That is the numerator of the function x in the bracket, and what is m? It is the coefficient of x in the exponent. As x goes to infinity, it will give us original limit of this special limit is 1 plus 1 over x the whole the power of like x as x goes to infinity. We know this e, but more general one is this one. So we have to convert what is given here, the limit, in the form of first one or the second form, and then we'll try to bring it the limit in this form. What is e? You know, e is an irrational number, approximately 2.7, but take it as it is, e. So let us try to simplify what is given to us here. So the given function is the limit of x over x plus 2 the whole the power of negative 3x as x goes to infinity. What we can do, we can divide each of the term by x. X over x will give us 1, and again x over x will give us 1 down. 2 over x will remain as it is. But we can break down this function and we can write it the limit of the upper part, 1 the power of negative 3x as x goes to infinity, the whole over the down part, the limit of 1 plus 2 over x the whole the power of negative 3x as x goes to infinity. But the upper part, 1 the power of whatever, okay, as x goes to wherever, it is always just 1 over, but the down part, according to the special limit concept what we explained before, it's going to be e the power of, here the constant, you can see the constant here, the numerator of the x is 2, and here the coefficient of x is negative 3. So these two numbers will be multiplied, it's going to be e the power of negative 6. But here the down part, the denominator part, the exponent is negative, so we can bring it up, it will be e the power of 6. So the answer will be A. The second question: what are the values of a and b so that what you see the function here, it is continuous everywhere, means on the set of real number. But the function, it is a piecewise function. It is 3 functions are there for x less than 1, and for x between 1 and 2, and for x greater or equal to 2. So first of all, the limit of the function f of x, we can say the function as f of x, as x goes to 1 from the left side, because as x less than 1 is there, it must be equal to f of 1. When I say the limit of the function as x goes to 1, I mean the functional value at 1, it will be the second function. So we are going to insert 1 in place of x in the second function, because the 1 or equal to is found here, it is. So when I substitute 1, it will be a times 1 plus b in the second function. That means the limit value, I will take the other function for the left side. That is going to be 1 plus 1. As x goes to 1 from the left side means for the upper function. Because the division is at 1 and 2, so first let's deal on 1. So when we are trying to find the limit of the function at 1, it must be equal to the functional value. The functional value f of 1 exactly found in the second part, because or equal to there. So the limit value, we need to take the other function. So here when you solve it, 2 is equal to a plus b. Let us keep it. Okay, the other division point is at 2. So again, the limit of the function f of x as x approaching 2, it must be equal to f of 2. But where is f of 2? When you try to see the function, x greater or equal to is found in the last one. So we'll take 3 times 2, we'll insert in the last function 2, and for the limit value I'll take the middle part. The limit, as x goes to 2 from the left, I will make it. So when I insert 2 in the second part, it will be a times 2 plus b. This is the same as 2a plus b is equal to 6. So now I do have 2 equations. This is the second one, here is the first one. Let us equate them simultaneously. That is a plus b is equal to 2, the first one, and the second one 2a plus b is equal to 6. Then we can subtract, since the b are the same here. When you subtract, the b goes, and a minus 2a will be negative a, and 2 minus 6 will be negative 4 if you multiply both sides by negative, so a is equal to 4. Once we have a equal to 4, we can substitute either in the first equation or in the second equation. The first equation, it says a plus b is equal to 2, so the a we got it 4 plus b is equal to 2, so b is equal to negative 2. We can shift it and we can get the value of b, that is negative 2. So what the answer for a negative 2, which is a. Next question, it is the same as what we did in the first. We have to convert this function in the special form, limit. That is going to be the limit. We'll divide each of them by 3x, because when you try to see here the function, it contains in the numerator 3x, also in the denominator part there is 3x. So we can divide by 3x, and we can make the leading term as, the first term as 1. So when you divide it, the upper part will be just 1, the lower part 1 plus 2 over 3x remain, the whole the power of negative 3x as x goes to infinity. This limit, it can be written again like I did before. The limit of the upper part, the upper part, just we can leave it as 1 over, and the lower part, the limit of 1 plus 2 over 3x. Okay, this one we can write it as 2 over 3 the whole over x. Just we need to keep the constant as numerator of x, so 2 over 3 the whole over x, and the whole the power of negative 3x, don't forget it, as x goes to infinity. This is equal to 1 over, now let's go to the down part. The down part, the whole thing is special limit. We said it e the power of the 2 over 3 will multiply 3. This one will multiply the negative 3 here. The two numbers, when we multiply, 2 over 3 times negative 3. So what will happen, the 3 will be cut here, and then 1 over e the power of negative 2 remain. Don't forget there is negative here, so this is equal to e square. So the answer will be just a. Next question, let us since I did this equation, this limit in the previous video, let me try to correct or change the question. What if it is the limit of like 5x e the power of x minus 3 absolute value of x the whole over x as x goes to 0 from the right, instead of what is asked here? What if we change it in this way? Here the game is on the absolute value, so the absolute value of x, it has two outcomes, either x or negative x, when x greater than 0 and when x less than 0. When x greater than 0 means as x approaching 0 from the right, x less than 0 means as x approaching 0 from the left. Here it says x approaching 0 from the right, so I will take the positive one, which is under this interval, so I'll take positive x, so I will remove the absolute value. The limit will be the limit of 5x e the power of x minus 3x the whole over x as x goes to 0 from the right. This time we can take out the x as a common. This x is common, we can extract. So when I take out x, what remain in the bracket? 5 e the power of x minus 3 remain. The whole over x will be there. Then we can cancel this x. We can cancel it. Then we can substitute now 0, because the limit is as x goes to 0, either right or left. If directly substitution is possible, we have to do it. So 5 e the power of 0 minus 3, that is 5 minus 3. E the power of 0 means just 1, so the answer is going to be 2. It will be changed. So the answer will be here 2. We don't have to find on the choice because the question is already changed. Since this question is done in the previous video by rearranging or by converting the coefficient number and the which side it approaches 0, we can do it in another way and we can exercise. The next question again, it is a special limit type. Let us recall. The other special limit is the limit of sin x over x. Okay, as x goes to 0, it will give us 1 by squeezing theorem. we try to prove this one, or it is proved in the grade 12 or pre-college students or college students. We know that the limit of sine x over x as x goes to 0, it is equal to 1. Not only sine x over x, actually x over sine x even it works, and tan x over x also it works, or x over tan x also it works. All of them, as x goes to 0, the limit, it will give us 1. That is a special limit. So now let us get back to our question here. Now what is asked here, what is the value of k? It says what the value of k. There is a piecewise function given at 0, it's divided, then it is continuous at 0, 0. That means we need to apply the limit of this function f of x as x approaching 0. It must be equal to the functional value at 0. But when I say f of 0, we need to take the second function, this part, because or equal to is found here. So I will substitute 0 in place of x. So it's going to be k minus e the power of 2 times 0 to be. For the limit part, I will take the first one, that is the limit of tan 2x the whole over x as x goes to 0. I will take the first one for the limit part. You know which limit, which side, it must be from the right, because x greater than 0 is there. Right or left doesn't matter, since it is continuous at 0, it's okay. So here the limit of this function, tan of what? It says tan of 2x. Okay, if this is 2x, the down part must be also 2x, but it is x, so I have to multiply by 2, here also by 2. But this coefficient number can be taken as a constant, and then tan 2x over 2x as x goes to 0, it will be 1. So 1 times this constant will be 2 remain, which is equal to k minus 1. You know, e the power of 0 will be 1. Then when we reshuffle, we will get k is equal to 0. But just to repeat, we need to be focused here what I did to the left hand side. Here it is. First of all, remember there was no 2x, I did nothing here. It was this one, here it is. This is the limit of tan 2x over x. Since tan of 2x, it says I was supposed to make this one 2x, so for that purpose I multiply by 2. When I multiply the denominator part by 2, I have to do for the numerator part also, but the numerator part 2 can be taken out as a constant. Here it is. And then now our limit become like standard form, like I said before, sine x over x or tan x over x. The limit as x goes to 0 will be 1. But whatever, not necessarily sine x over x, by the way, not necessarily sine x over x. It can be sine 4x over 4x or sine 5x over 5x. It doesn't matter. Here it has to be the same anyways. So for tan also the same. That's why I'm trying to multiply by 2 both numerator and denominator, but the numerator part 2 is taken out, and then this limit will be 1 times 2 remain. And the right side, since f of 0 is the second part taken, then I substitute 0. 2 times 0 is 0, and e the power of 0 is 1, so k minus 1 remain. So when you bring the negative 1 to the left side, it will be added with 2, and then the answer will be 3, that is B. Next question, it is limit. The limit of, it is x cubed minus 8 over x squared minus 4. I'm not sure whether I did this equation before or not, but let me repeat it. If it is done, let me repeat it. It's okay. Let us factorize, because direct substitution doesn't work here. If you insert 2 in both in place of x, it will be 0 over 0. So let us factorize. The down part, when you factorize x squared minus 4, it will be very easy. It's going to be x minus 2 and x plus 2. You know, difference of square, because 4 is 2 square, and x squared minus 2 square will be x minus 2 and x plus 2. What about the down part? I mean the numerator part. X cubed minus 8 means, you know, 2 cube. So we need to apply a cube minus b cube. That's going to be x minus 2, then x squared plus 2x plus 4. Then this limit will be the limit of the upper part, x minus 2, then x squared plus 2x plus 4, and the lower part, that's going to be x minus 2 times x plus 2. So as x goes to 2. So what to do here? Let us cancel x minus 2. This was the problem. Then directly we can insert 2. When insert 2 here, it will be 4, 4, 4. It's going to be 12. and the down part 2 plus 2 4, so the answer is going to be 3. That's B. Next question, again this is kind of a special limit. F is continuous at 0, and what's the value of A since the function is piecewise? So again, like I did previously, the limit of this function f of x as x approaching 0, it has to be the same as f of 0. Okay, so when I say f of 0, which must be taken? Which function must be taken? The second one. The reason, as you see, or equal to is found in the down part. In the second part, here it is. So it's going to be e the power of 2 times 0 minus 2 remain to the left hand side, I mean the right hand side. To the left hand side, okay, let me use my space properly. For the left hand, it's going to be the limit of the first function will be taken, a times sine of 2x over x as x goes to 0. 0 which side? From the left side, obviously, but left or right doesn't matter because functional value already, the second one will be taken already, e the power of 2 times 0 minus 2. Then here the a is constant, so it doesn't have effect, we can extract it, but try to observe now. Sine of what? 2x over x, it says. So I have to multiply here by 2, and the upper part also will be multiplied by 2, but that 2 will be remain with a, will be multiplied and remain with a outer, so it will be 2a remain. You know, sine 2x over 2x will be, as x goes to 0, just 2a, which is equal to, here this is 1 minus 2. So 2a is equal to negative 1. When you divide by 2 both sides, it is going to be a equal to negative 1 over 2. So the answer is going to be just C. This is similar question like that of what you did in the previous year. Yeah, it is similar almost. Now let us see how to solve some quadratic problems. The first question, 2x squared plus 13x plus, this must be plus, take care, is equal to 15. First of all, let's have some general information. Quadratic equations are x squared plus bx plus c equal to 0 form. So any quadratic equation can be solved by 3 different methods. Formula, that is most commonly applied, and the formula is negative b plus or minus the square root of b squared minus 4ac the whole over 2a. This is the formula to get x. The second method is factorization, and the third method is completing the square method. But if we are asked like to solve any quadratic equation, it's better to apply the formula, because the formula is, you know, it's unique, and at the same time it will work for any quadratic equation. So it's better to apply the formula and solve quadratic equation. Let's do it. So in this quadratic equation, what is a? First let's identify the coefficient of x squared is a, that is 2, and what's b? 13, and what about the c? It is 15. So x is equal to negative b plus or minus the square root of b squared minus 4ac the whole over 2a. First of all, we can solve the discriminant, or the one which is found in the square root. If it is negative, if this will give us negative result, so the given quadratic equation will not have solution. So let's do that one. So b squared minus 4ac means the b squared is 13 squared minus 4 times 2 times 15. 13 squared is 169, and this is 60, that's 120. You know, 4 times 5 is 60 times 2, 120. When we subtract, it's going to be 49. Okay, so it's not negative result, so we can proceed, it's positive. So x is equal to negative b is negative 13 plus or minus the square root of 49. We got it already. The whole over 2a means 2 times 2, that is 4. So that's going to be negative 13 plus or minus 7, the whole over 4 remain. So x value, one of the value, or x1 I can say, x1, negative 13 plus 7 is negative 6 over 4. Negative 6 over 4 means negative 3 over 2. That's one answer. The other answer, x2 I can say by minus 1, negative 13 minus 7 will be negative 20 over 4. That's going to be negative 5. So there will be 2 possible solutions here. Since the discriminant is greater than 0, the given quadratic equation will have 2 answers. The answers are negative 3 over 2 and negative 5. If the discriminant becomes 0, the given quadratic equation will have one solution. If it is negative result here, the discriminant part, this is what you call it, discriminant. This is a deciding factor. If this result give us less than 0 or negative result, the given quadratic equation will not have roots or zeros, or it may not cross x-axis. Okay, this is also another quadratic, but it needs some kind of simplification because it's not written in standard form. First one here already written in standard form, so we need to square here both sides and then reshuffle and simplify first. Let us square it. X minus 1 square means x minus 1 times x minus 1. Then we can expand. We can do it in that way, like x times x and x times negative 1, and again negative 1 times x and negative 1 times negative 1. The same thing for the second part, 3x minus 3 and 3x minus 3. You can do it first and then negative 3x, and each of them will be multiplied. We can expand by binomial expansion process. But as to me, what is better, remember a minus b the whole square. A minus b square means a square minus 2ab plus b square. If you like this method, you can follow. If you don't like it, you can proceed with the first what I said. So x minus 1 square, according to formula, it will be x square minus 2x plus 1, which is the second part also 9x square minus 18x plus 9 to be. So when you reshuffle and when you collect it, 8x square minus 16x plus 8 is equal to 0 remain. Then this quadratic we can simplify by dividing by 8 each of them, because as you see the coefficient numbers are multiples of 8 all. So x square minus 2x plus 1 is equal to 0. Then this one can be solved by the formula, but as to me, I can factorize it, and x minus 1 the whole square is equal to 0. This is the same as the first part, so we can put in the square root, but we can apply the formula here. Don't forget, formula can be applied here, but I'm doing it by factorization process. So square and square root cancel, and x minus 1 is equal to 0 remain. That means x is equal to 1 will be the answer. It has one solution only. Okay, our next equation will be exponential equation. First one, 2 the power of 3x minus 4 is equal to 1 over 8 times 4 the power of 2x plus 1. First of all, let us try to recall some exponential rule. A the power of m plus n, a the power of m times a the power of n is the same as a the power of m plus n. When you multiply two exponents having the same base, you can take one base and add the exponent. In case of division, you can subtract. There are rules, So here, the left hand side is base 2, but the right hand side there is 1 over 8 and 4, but we can convert them in base 2 form. So we can write 2 the power of 3x minus 4 is equal to 1 over 8 can be written 2 cube. Again, the bracket part, the 4 can be written 2 square, but that square will multiply the other exponent 2x plus 1. Don't forget that. This is the same as 2 the power of 3x minus 4 is equal to, here when you bring it up, 2 the power of negative 3 it will be times 2 the power of, then this has to be distributed and multiply each of them. It's going to be 4x plus 2. Then let's complete this one. This is the same as 2 the power of, we can add the exponent 4x minus 1. 4x as it is, but negative 3 plus 2 will be minus 1. So what do we left now? 2 the power of 3x minus 4 is equal to 2 the power of 4x minus 1 remain. Now since the bases are the same, we can ignore and take the exponent. 3x minus 4 is equal to 4x minus 1. Then collect it. Negative x is equal to 3. When we reshuffle, the 4x will be subtracted. So x is equal to negative 3 will be the answer. Anyways, what do I apply? First, if I just write this one exponential form with base 2, here it is, and the 4 also the same thing to square, and then I brought it up. When I bring it up, the exponent become negative, and here distributed, and then since it is multiplication, I just add the exponent. here it is. Finally it is condensed and simplified. There will be two exponents, right and left hand side, having the same base, so we can ignore the base and take the exponent. That's what's done. Let's go to the second one. The second one again, the left hand side is 5 the power of, base 5, but the right hand it is just 1 over 25, but 25 can be written as base 5, it can be written as 1 over 5 square, and which is 5 the power of negative 2. Now when you try to see the left and the right, the right hand side is simplified. This is the right hand side, and the left hand side, here it is. The two have the same base, you can ignore and take the exponent. X minus x square is equal to negative 2. Then we can reshuffle, collect, and we can have x square minus x minus 2 is equal to 0. By reshuffling you can rearrange and you will get this result. Or you may get like negative x square plus x plus 2 is equal to 0. By the way, the two are the same, these two are the same. Okay, it's all about if you multiply by negative, all the same. Then you can solve this one by quadratic formula or by factorizing. But as to me, x minus 2 and x plus 1 is equal to 0. I factorized it because product negative 2 and sum negative 1 are negative 2 and 1. So x is equal to 2 and x is equal to negative 1 will be the final answer. You can do it by formula after this. Formula can be applied here and you can check it. So these are some of selected quadratic equation and exponential equations. Now let's go to linear equations with two variables or simultaneous equation. The first one, 7x minus 2y is equal to 4, and the other one is 5x plus y is equal to 15. What to do here? Try to make the coefficient of the x or the coefficient of the y's are the same. Which one is preferable from this equation? The y's are easy to make the same, because here it's 2, here it's 1. So the second equation can be multiplied by 2 each of them. The first as it is, 7x minus 2y is equal to 4, and the second multiplied by 2 each of them, it will be 10x plus 2y is equal to 30. Then add it, because the y's are the same but the coefficient, the coefficient number is the same but they are opposite inside, so we can add it to eliminate. This process is said to be the process is said to elimination method. The method, there are three methods to solve a system of linear equation with two variables: substitution method, elimination method, and graphical method. But elimination is the best as to me. So what to do here? We can cancel negative 2y and y when we add it, and 7x plus 10x will be 17x, which is equal to, when you add the other side, it will be 34. If you divide by 17x is equal to 2. So if we have the x value, you can insert it either in the first one or in the second one. The first equation, it says 7x minus 2y is equal to 4, bring the 2 here, it will be 14 minus 2y is equal to 4, and then bring 4 here, 14 minus 4 is equal to 2y. So 10 is equal to 2y means if you divide by 2 both sides, y is equal to 5. So we have got the two values of the values of x and y that's unique, 2 comma y. So the solution set will be just 2 comma 5. We can write it in this way. First order is x, second order is the y1. Okay, let's go to the second equation. Again, the second equation here, it's very easy to make the y's are the same, because the first one coefficient 2, the second one coefficient 1. Let's multiply the second equation by 2. So the upper part as it is, 5x plus 2y equals 6, and the lower part, negative 4x when you multiply by 2 plus 2y is equal to negative 12. This time we are not going to add, because the sign are the same, plus plus, so I have to minus, I have to subtract. By subtraction it will be eliminated the y, but 5x minus negative 4y, there are two negatives here. When you minus, it will be minus will be plus, 9x remain. The same thing here, 6 minus negative 12 will be plus 12, 18. If you divide by 9 both sides, so x is equal to 2, and bring and insert in place of the second equation. Negative 2 times 2 will be negative 4. Let me write negative 4 here. Negative 4 plus y is equal to negative 6. When you shift it, y is equal to negative 2, you know, it will be added. So that's going to be the answer. Okay, the last question here. Again here, in the last equation, it's better to multiply the second equation by 3, or already the x's are the same actually, no need to multiply, the x's coefficient are the same, 6x, 6x, so we can subtract. When you subtract, the x will be eliminated, and 3y minus negative y, you know, minus minus will be plus, so it's going to be 4y, which is equal to 33 minus 5 will be 28. If we divide by 4, y is equal to 7. That's going to be the answer. And then bring the y7 in first equation or in the second equation. Better in the second equation. 6x minus 7 is equal to 5, because in place of y I substitute 7. So 6x is equal to 12. When this go, it will be added, divided by 6 both sides, so x is equal to 2. That's going to be the answer. So these are some of revision question on system of linear equation with 2 variables. Next question, let us see some function. Highlight again. 2 functions are given here, f of x, here it is, and g of x, here it is. Then a says f plus g at 1. This is the same as f of 1 plus g of 1. According to the rule, f plus g at any point is equal to f at that point plus g at that point. So at 1, f plus g at 1 means f at 1 plus g at 1, according to the theorem. So this is equal to f at 1 means we will insert 1 in place of x in the original equation of the f of x. So 2 times 1 square minus 3 times 1, because f of x is equal to, as you see, f of x is equal to 2x square minus 3. So if I say f of 1, I will insert 1 in place of x. That's what I'm doing. So let me write it properly. 2 times 1 square minus 3 times 1. This is f of 1 plus, what about g of 1? Insert 1 in place of x in the g. So 5 times 1 plus 10. So this is f of 1 and this is g of 1, at the middle it's plus. So 1 square 1, 2 minus 3 will be negative 1, plus here 5 plus 10, 15. So when you add it, it will be 14. Second one, f minus g, that's b, f minus g at negative 3. Again we can expand this, f at negative 3 minus g at negative 3. F at negative 3 means, let us insert in place of x 2 times negative 3 square minus 3 times negative 3. This is just f at negative 3. We can make it big bracket here, minus the second one, g at negative 3 means again 5 times negative 3 plus 10. Let us finish it. This is 9 times 2, 18, plus 9 again, because negative 3 times negative 3, it will be 9, minus here negative 15. Negative 15 plus 10 will be negative 5, but negative, okay, let's keep it negative 5. Then let us complete it. The sum of this will be 27. So 27 plus 5 remain, you know, negative will be positive, so that's going to be 32. So we need to take care of this negative, you know, it will be distributed. Here it is. Finally, okay, it may change what is found in the bracket. If it's negative, it will be positive. If it is positive, it will remain negative as it is. So these are the answer for the first one and the second one, A and B. Let us do C and D. What does it say? C, f times g at 3. Again, this is the same as f at 3 times g at 3, which is f at 3 means we would insert 3 in place of x, in place of f of x. 2 times 3 square minus 3 times 3. This is f at 3 times g at 3 again, 5 times 3 plus 10. So when you finish it, this is square. 3 square 9 times 2, 18, minus 9 will be multiplied. This is 15 plus 10, 25. So that's going to be 9 times 25. So when you multiply 5, 4, 225. Yes, that's going to be the answer. And at last, f over g at negative 2. F over g at negative 2 means f at negative 2 over g at negative 2. The good thing here, f of negative 2 over g at -2, when you insert it will be 0. So whatever over 0 will be undefined. So the last one, D, the answer will be doesn't exist. The next one, how to find the domain in the range for graphically, whatever it is given, how to find the domain in the range. To find the domain, we need to apply vertical line test. When you draw a vertical line anywhere, does it touch the shaded region? For example, I draw here, it touches. What about here? It touches everywhere, because the shaded region is expanding in every direction. So when you draw a vertical line anywhere, it touches the shaded region, so that's going to be the domain will be x is an element of real number, we can say. So for domain, what the checking mechanism is, simply draw vertical line and then check anywhere. Does that vertical line touch the shaded region? Will decide. Anywhere if you draw, it will touch the shaded region, so that the domain will be the set of real number. What about the range? How to check the range? When you check the range, we are going to check by horizontal line test. If I draw horizontal line, here it touches, here also it touches, everywhere it touches here. But below this point, okay, the main point is here. After this point, anywhere if I draw, it doesn't touch. So the range will be above this point. What is this point? We have to get it. If you can read it graphically, it's okay. If you can get this point, actually I think it's 1. But if you cannot get this point, like if it is not visible or if we are not sure, we have to take the two equations. The two equations are x minus y is equal to 3, and the second one is x plus y is equal to 5. Forget the inequality and then take it as it is. And then since we need to find the range means it's all about the y. The range means it's all about the y. So let us keep the y and let us try to eliminate the x. To eliminate x here, we need to subtract, x minus x will go, and negative y minus y will be negative 2y, and 3 minus 5 will be negative 2. If you divide by negative to both sides, so the y is equal to 1. Okay, yes, as I said before, it's visible, so the two graphs meet at 1. That means the shaded region will remain above 1. Okay, our horizontal line test, okay, will work above 1. So the y must be greater or equal to 1, the range. Below 1, it doesn't touch. Anywhere if you draw here, okay, horizontal line, it doesn't touch the shaded region. The line or the horizontal line start touching at 1. After 1, anywhere above, if you draw, it can cross the shaded region. That is horizontal line test to check the range. Let's add one more here. In this graph again, if you draw horizontal line anywhere, it will have the ability, or it can touch the region, because this will expand, it continues down also anywhere. That means our domain here, the domain will be x is an element of real number, because by horizontal line test the graph will be crossed, or the region will be crossed by any horizontal line, anywhere up or down. What about by vertical line test? By vertical line test, we cannot cross it here, we will not get it here, any horizontal. The horizontal line start touching after this point. What is this point? We have to get it. After this point, any horizontal line, it will cross the shaded region. So what is this point? Let's get it. As I said before, let us take the two equations. The two equations are negative 3x plus 5. I mean the first one, y is equal to negative 3x plus 5. The second equation, y is equal to x minus 2. So we can substitute. Let us substitute this y in place, or let us make the two equal. X minus 2 is equal to negative 3x plus 5. Why? Because both of them are like y, so we can take them and equalize. So by reshuffling, 4x is equal to 7, so x is equal to 7 over 4. So the x point, the domain, not the domain, the first one, what you said, the range, it must be. This is a range. The range is y is an element of real number, because by horizontal line test we will check the range. The range is the set of real number, don't forget that. Now we are doing for the domain. The domain, by vertical line test, we'll check domain. Take care. Domain will be checked by horizontal line, vertical line test. Vertical line. And range will be checked by horizontal line. So by horizontal line, for this graph, anywhere it will be crossed, so that the range will be the set of real number. Don't forget it. What about the domain? The domain will be, the vertical line test will check, cross the graph after the point which is intersected here. What's this intersection point? This meeting point or intersection point of the two graph, since I equate them by substitution, I have got x is equal to 7/4. So x must be greater than 7/4, not greater or equal to. The reason, the two lines, one broken line, the other one is solid. If both solid line, I will say greater or equal to line 7/4. But one of the line is broken, the other line is solid, so I have to say just greater than. So in this way we can check the domain and range of a given drawn linear inequalities with two variables. So that is enough for today. Thank you for watching.